Okay, in this part of our lesson, we're going to be working with direct variation. So we're going to be using our skills that we had back in section 1 with graphing equations by substitution. First of all, let's review once again what our direct variation is. When two quantities, x and y, are proportional, the relationship can be represented by the direct variation equation of y equals mx. Okay, so y equals mx, where m is going to be your constant. Sometimes this equation is also written as y equals kx, which is what we reviewed in our activity. Okay, the k is representing our constant. In this situation, our m is going to represent our constant proportion, which is going to actually be our slope. So it's going to introduce us into part of the slope-intercept equation. When we graph this, we're going to be graphing y equals mx in a line where the slope of m, which is what m represents, passes through the origin or 0. So once again, it has to have a proportional relationship and it has to pass through 0, 0 in order for this situation to have a direct variation. So we're going to work a little bit with that. Okay, so here's our first scenario. We're going to be graphing a proportional relationship. It says the cost y in dollars for x gigabytes. So they're telling us what y is and what x is of data on an internet plan is represented by y equals 10x. Graph the equation and interpret the slope. So we're going to go ahead and we're going to use this equation and we're going to go ahead and pick some numbers that we want to use for x. So that's the equation that we're going to be using. So we're jumping back to what we did back in one of our earlier lessons. So noticing just how I already have the table already set up, let's go ahead and use numbers 1, 2, and 3. If you want to use some of the others, that's okay. But just because I already have the table set up only going through 6, let's not use a number greater than 6. So let's go ahead for x's. We'll do 1, 3, and 6. How about that? It wouldn't matter if you used 1, 2, and 3. If you used 0, 1, 2, 3, because it does not involve a fraction, we can go ahead and pick whatever number we want. So I'm going to go ahead and substitute in y equals 10 times 1. Okay, so 10 times 1 gives me 10 for y. Y equals 10 times, this time I'm putting a 3 in there, 3, which would give me 30. Y equals 10 times 6. So 10 times 6 is 60. If I wanted to, I could go ahead and do another one just to prove my point. Y equals, let's do 0. 10 times 0. So 10 times 0 is 0. The one thing that's nice about using 0 is then we can actually see right away whether or not it crosses through 0, 0, which is one of the qualifications that it has to have. Okay, so now we're going to go ahead and plot our points. Okay, over to 1, up to 10, over to 1, up to 10, put our dot. That one's done. Over to 3, up to 30. And if you picked different ones, well, then your graphing is slightly different. But we should end up with the same line. Over to 6, up to 60. And then I also had 0, 0, which happens to be plotted already right there. So I'm now going to check to make sure it's a straight line. And it is. And it would continue in that direction forever. If we were to continue using higher numbers, we could extend our graph. So there we've graphed the equation. The last part says interpret the slope. So once again, we need to review what the slope is. Well, the slope is the rise and the run. But in our equation, this part right here, that y equals mx, the m, whatever number is in place of m, is actually our slope. Okay, so the slope was 10. Well, what the heck does 10 mean? So it says the cost, it cost us, for example, if I were to pick one of these points, I'll pick this one right here just to kind of break down what we're learning from this graph. Our cost, so our $30, because that was our Y, was representing 10 times our gigabytes, which was 3. Okay, so what was this representing? Well, it was costing us $10 per gigabyte. So the slope in this situation, what does the slope represent? The cost per gigabyte. Okay, so that's just interpreting. So far, we've done a lot of graphing, but not really understanding what those graphs are representing. Okay, so that's what we'll be practicing in this part of the lesson. All right, let's go ahead and try another one. It says, what if the cost, let me delete this off there. What if the cost is represented by Y as 12x? Graph the equation and interpret the slope. So this one, I'm not going to go ahead and graph the equation because I forgot to put a graph on here, but you guys go ahead and graph it on your whiteboards. Okay, so you might have to, I'll kind of do a rough sketch of a graph, but I'm not going to have the perfect coordinate pieces there. So this time I'm going to represent 12. So this time it's going to cost us $12 per gigabyte. Okay, so graph the equation and interpret the slope. So we just interpreted the slope. It's going to cost us $12 per gigabyte. So let's pick some numbers. So we'll maybe use 0, 5, 10. Remember, you can pick anything. If this right here, if our M or our slope is a whole number, we can pick anything that we want. So if I were to put 0 in there, well, 12 times 0 is going to give me 0 for my Y. If I did 12 times 5, that would give me 60. And then 12 times 10 is going to give me 120. Okay, so the bottom of my graph, well, these are representing, this was our cost in dollars. Okay, and this was our number of gigabytes. And you could look back at the original graph. I just didn't have it pulled back out. So I'll go ahead and do this as 0, and I'm just going to mark every 5. Okay, and then going up, I could go maybe by 20s, just because I'm noticing these are all multiples of 20. So maybe this is 20, 40, 60, 80, 100, 120, and I could continue on, but that's all the further I need to go. The one thing you have to realize is when you freehand something, your line may not look perfect when you're doing this. It's best to have probably a graph that's already created so that as you're putting in your numbers, you know that each of these is equally spaced. Okay, so now if I go ahead and do this, I'm going to go over to 0, up to 0, and put a dot. So it does cross through 0, 0, over to 5, up to 60, over to 5, up to 60, and then over to 10, up to 120. And it does create a pretty good straight line. Okay, so there's our graph of what it would cost if each gigabyte was $12. Okay, if we were to kind of compare, it makes that slope go much more upright than the previous one. Okay, so I want you to go ahead, pause your video, and work your way through this sample. So once again, our equation is going to be P equals 9H, where P is your number of dollars that you earn by working H hours. Okay, so they want you to graph the equation, and then they also want you to go through and interpret what that slope is. Remember, our slope is this 9 part. Okay, our Y equals MX. This part right here is our slope. Okay, go ahead, pause your video, work your way through this one and see how you end up with on your graph. Okay, you should have ended up with your graph looking something slightly like that. Once again, I had 10 between each of these boxes, so it's really hard for me to graph that 72. So I'm slightly off probably on my numbers, but in general, it looks like they're pretty close to a straight line. Okay, so had I done my graph maybe by fives, it would have been easier to get it more precise. So we graph the equation. We also need to interpret the slope. So what does this 9 represent? Well, that represents that we're going to get paid $9 per hour. So we're making $9 per hour at this job. Okay, that's it for this part of the lesson. So once again, y equals mx is our first part of our new process, knowing that m represents the slope of our equation.